Okay, here's three questions that are quite mathematically driven, uh, but I guess they also impress upon our minds what these rules are. First one says I have a sample of argon gas occupies a certain volume at 25 Celsius. So 25 Celsius plus our 273.15 will give me 298.15 Kelvin. Okay, at what temperature will the volume of the gas be 3 times as big? So they want to know what my new temperature is, and they want to go from any volume here to triple that volume there. So let's call this one x, and we'll call this one 3x. Now, and I guess when you're looking at this, they say the pressure remains the same. That's a wash. How many moles are in there is a wash too. So if you look at it, this is classic Charles law, where if the temperature goes up, the volume is going to go up, and it goes up by a certain ratio. So if you take and you triple the volume, then all you have to do is take your 298.15 and times that by 3. And whatever you get to that, 894, whatever it is, 0.45, that'll be your new temperature. This is Kelvin, so if you subtract 273.15, I think you get something close to the 621. Okay, so that's a nice Charles law question. Here's another example of gas in a container fitted with a piston that can move around and has a temperature above 0. Okay, well, let's call it 10. So if the temperature is 10, then temperature in Kelvin will be 283.15. Okay, now if the Celsius temperature is doubled, so I said Celsius 10, so doubled would mean 20 Celsius. Convert that to Kelvin, it'd be 293.15. Okay, then they say what's true about the ratio of the final volume, so V2, this one, to V1. Well, let's look at our formula right here. And they want the ratio of V2 to V1. If I manipulate this formula, I can do this. So V2, if I solve for that, it'd be V1 T2 over T1. But I want V1 over here because I want the ratio of the final volume to the initial volume, V1. So if I divide both sides by V1, I get that actual ratio. These cancel out. So all I have to do is take the final temperature and divide it by the initial temperature. So if I take 293.15 and divide it by 283.15, I'm getting 1 point something. So here they're saying, and hopefully that's one of the options, here they're saying that the ratio is always less than 2 to 1. If you wanted to, you could try and plug in any number there that you want for the initial temperature, like plug in 1,000. And then this one would be 2,000, and figure out the ratio, and it's going to be less than 2 to 1. You can try that. Okay, the third question, 2 balloons, both same size and same temperature. Okay, as long as they're exactly the same kind of balloon, that means they'll expand and contract the same depending on how much gas is in there. So it doesn't matter what type of gas it is, and some gases are heavier than others, but the amount of pressure that they put on the side of the balloon is dependent on how many moles of gas they have. So if they're the same size, that means not only is the volume the same for both, but also how many moles of gas are in there are the same. Okay, but they also say it's the same temperature, so this is a wash. So if all of these are the same, then it follows that the pressures must also be exactly the same. All right, hopefully that helps you with those 3 questions.